So today what we're going to talk about is distance or displacement and distance traveled, but this time we're going to get our information from a graph, okay? So here we go. A soccer player runs back and forth along the ground. The horizontal position of the soccer player is shown below. So you can think of the soccer player as literally going like left and right if you're in the stands and watching the soccer game, okay? So zero somewhere, we're calling zero somewhere on the field, okay? So this -6 would mean he's to the left of wherever you're calling zero. And that's where he starts initially, okay? And then after 8 seconds, he's moved further to the left and now he's at -15. So he's at that position -15, okay? And then at 12 seconds, he's at the 0 mark, okay? And then at 16 seconds, he's at 15 meters, and now we're at 15 meters, and that's positive, so that would mean to the right of whatever we're calling the mark in the field, 0. It could be like, you could think of football and being like the 0 being like the 50-yard line, okay? All right, and then after that, at 24 seconds later, he's back at that 50-yard line, or the 0 mark. We'll call it the 0 mark, and then you can go right and left of that, okay? All right, so the very first thing that they're asking you here is, what is the displacement of the soccer player between 0 seconds and 16 seconds? Okay, so you got to realize that displacement means just the change in position from where you started to where you ended, not all the movement in between, okay? So our x of f, our final, and our initial, okay, let's start. I wish I would have written x of I first, okay, our initial, is at this t equals 0, and that's where we start the soccer player at, okay? He's initially at -6. So x of I is equal to -6, and we say these are in meters, so -6 meters. And the final position would be after the 16 seconds, and I should say this is at t equals 0 seconds. And then x of f, the final position, and the final position is not the final position after everything, but it's the final position after this 16 seconds. And that would be right here, right after 16 seconds, it'd be at 15. So x sub f, okay, is 15 meters at t equals 16 seconds, okay? And this would be our, because we want to find the displacement, and this would be the end of it, right? This would be the final position, and the time that we're reached there is at 16 seconds. So our displacement is delta x, okay? And delta x always represents the change in position, which would mean displacement. And that formula is x sub f minus x sub I. And so that means delta x is equal to 15 meters minus, and then -6 meters. Now that makes adding, right? So that makes 15 plus 6, which would be 21 meters. And that would mean, because we're going left and right, he would be 21 meters after 16 seconds. He'd be 21 meters to the right of where he started from, okay? Because that's positive, we're saying to the positive part. I should actually even put a positive in here, okay? All right, so he's 21 meters from where he started, okay? Now, what is the distance the soccer player traveled between 0 and 16 seconds? So now we got to count up all the movements, okay? So he moved from here to here, right? He went from -6 to -15, okay? And then he went from -15 in one swoop to 15, and that would be the end of 16 seconds, okay? So I'm gonna write here off to the side. We can use the displacement for each of these to figure out the total distance traveled. So between 0 and 8 seconds, okay, our delta x would be -15 minus -6. And so that'd be -15 plus 6, which is equal to -9 meters. Okay. Now, the negative just tells you the direction. That would mean he went left, and he went left 9 meters. Okay, so the distance traveled between 0 and 6 seconds, we would write, okay, so distance traveled and we would write 9 meters and then plus, and then we got to do this next section from 8 seconds to 16 seconds. So we also have to find this between 8 seconds and 16 seconds. So we're just really doing each of these segments. So my delta x there, okay, so my final position at 16 was 15. So this would be 15 minus, and what position did I start at? I started right here at negative 15, right? And when I say start, at the beginning here at 8 seconds. So that 15 minus negative 15, and that'd be 15 plus 15, which is 30 meters. Okay, so what does that positive 30 mean? That means he moved to the right between 8 and 16 seconds. He moved to the right 30 meters. So here he moved left 9 meters between 0 and 8 seconds, and here he moved 30 meters. Okay, so we're going to add 30 meters. So that means the total distance traveled is 39 meters, because that would be between 0 and 16 seconds. Okay. All right, I'm going to slide this up a little bit. We're just going to do a different one, okay? How about between 8 and 24? Okay, between 8 and 24. So between 8, so at the start of this, right, we're starting, that would be my initial, and this would be my final. So x sub I, I'll do it right this time, okay? X sub I would be at 8 seconds, and at 8 seconds, we're starting at negative 15 meters. And this is at the 8 seconds, because that's when we're starting. That would be the initial, okay? And then x sub f would be the position at 24 seconds, and that would be 0 meters at 24 seconds. So our delta x would be x sub f minus x sub I, right? So that'd be 0 minus negative 15 meters, right? And I should put 0 meters in here, but that becomes 15 meters. So the change is 15 meters to the right from 8 seconds to 24 seconds, he moved 15 meters to the right. Okay. All right. So now, what is the distance soccer player traveled between 8 seconds and 24 seconds? Okay, so 8 seconds and 24 seconds. So that would be this one. That'd be 8 to 16. And then we'd also need to do 16 to 24. So now we need to add this one, between 16 seconds and 24 seconds. Okay, so my delta x would equal, okay, so the 24 is my final one, so that would be 0, minus my initial one with this time would be at 16, because that's where I'm starting this, and that was 15. So 0 minus 15 meters, and that would be negative 15 meters. Okay, now that means the change is negative 15. He traveled 15, but in a negative direction, which would mean, in this case for the soccer player, left probably, okay? So the distance traveled, we got to figure out how far he traveled from 8 to 16 seconds. And then from 16 to 24. So between 8 and 16 seconds, he moved 30 meters. So that'd be 30 meters plus, how far did he go between 16 and 24? And he went 15 meters in a negative direction, okay? So that'd be plus 15 meters. And that would give you 45 meters. And that's how far he traveled, okay? Some people can look at this and go, okay, you went from negative 15 to 15, that's 30. right? Because you went 15 here and another 15. And then you went another 15 right here because you went from here to here. And that's from 15 to 0, you had to have traveled 15 meters. So some people can do it that way too, okay? All right, so his distance traveled would be 45 meters. Let's do another one. So for this next example, we're in an elevator that travels up and down. So up would be positive and down would be negative, okay? And the vertical position of the elevator in meters over time is shown below. So 0 is probably, I didn't say this and you really don't need to know this, but 0 is probably like the ground floor, and this would be the top floor, okay? And then this would be like going into the basement, okay? Or below ground, okay? All right, so the first question is this: what is the displacement of the elevator between 0 seconds and 16 seconds? Okay, so once again, you got to realize that displacement is not how far it traveled. Displacement is actually the change in position from 0 seconds to 16 seconds. So what is the initial position? And we're starting this at 0 seconds. So at 0 seconds, we're at 12 meters. So this would equal 12 meters. And this is at 0 seconds. And then x of final, the final position, right? The final position, and that would be at 16 seconds. At 16 seconds, we're at 0 meters. That'd be right here, okay? So 16 meters, or sorry, 0 meters at 16 seconds. Okay, so my displacement is always gonna be delta x is equal to x sub f minus x sub I. So in this case, it'd be 0 meters minus 12 meters, which would give you negative 12 meters. So what that means is the net change between 0 and 16 is they went down from where they started at, they went down, because the negative, 12 meters, okay? Something I meant to say before this, okay, and talk about this position a little bit. Okay, so what does this mean? At 0, it's 12 meters. Okay, take a look. At 8 seconds, it was still 12 meters. So what that means is the elevator is not moving right here. Okay, see this flat part? It's staying the same position for 8 seconds. So, okay, and so it's not moving. That's going to be important, okay? The next thing here from 8 seconds to 16 seconds, right? All right, we could get a displacement there, and then we can get a displacement here. It bent a little bit right there, right? So it's going a little bit faster, and then it's going back up. So at 16 seconds, it's at like ground floor. I should have said that. Then at 20 seconds, it's negative 15. So that'd be like negative 15 meters below ground. And then at 24 seconds, it's at negative 6 meters. So that'd be like 6 meters below ground, okay? But at 28 seconds, it's still at negative 6. So what happened again? Again, right here, it stopped and stood still for a little bit, all right? And then from 28 seconds to 32 seconds, all right, at 28 seconds, it was still at negative 6, right? And was there for 4 seconds. And then it went from negative 6 meters to negative 12 meters at the end of 32 seconds, okay? So here we go. What is the distance traveled between 0 seconds and 16 seconds? So we can break this up into the segments, okay? So we can go between 0 and 8 and between 8 and 16, okay? So between 0 seconds and 8 seconds, we know our displacement, our delta x, would be, okay, so after 8 seconds, our position is at 12 meters minus, what was our starting? 12 meters. So that gives us 0 meters. Okay, so what does that mean, 0 meters for a displacement? It means it didn't move, okay? So during that time, it did not move, okay? Or I shouldn't say it didn't move. You could have a 0 meter displacement and it moved, okay? It was just that these would have to be the same, okay? And then let's go between 8 seconds and 16 seconds. And that would be this segment right here, okay? And so that would be our delta x Our final would be at 0. And we're going to subtract. And then what we started with was at 8 seconds, right? And in 8 seconds, we were at 12. And so that would give you, as long as you have units on the end here, that'd be good. Like I didn't put them individually here. So that'd be negative 12 meters. Okay. All right. So what does that mean for distance traveled? Okay. So for distance traveled, between 0 and 8, we didn't travel anything. Between 8 seconds and 16 seconds, we went down 12 meters. Well, we traveled 12 meters, right? So our distance traveled would equal 0 meters plus the 12 meters, which would give you 12 meters. All right. Okay, let's go to the next one. How about between 8 and 28 seconds? What is the displacement? Okay, so x of I is going to be the one at 8 seconds. So where were we at 8 seconds? Well, at 8 seconds, we were at 12 meters. At 8 seconds. And then the final would be our position at 28 seconds, and that would be -6. So -6 meters at 28 seconds. And I'm going to slide it up so you can see it a little bit more better. Okay. And so what's the displacement? Well, the displacement is the change between the final and the initial. So delta x is equal to x sub f minus x sub I. So that means in this case, my delta x would be -6 meters minus 12 meters. And that would be -6 minus 12, or -18 meters. So what that means is from the start, okay, it went down, because we're talking about up and down, and it went down 18 meters from where it started. Okay, so between 8 seconds and 28 seconds, it went down 18 meters. Okay, let's go to the last one. Okay, and I'm going to zoom out just a little bit, just so we can see everything. And I had a bad glare, so sorry about the shadows. I had to turn my lamp off. Okay. All right, so here we go. What's this next one? What is the distance traveled between 8 and 28 seconds? Okay, so we already have up here between 8 and 16. That's this segment. Okay, we need to get all the way over here to 24. So now we need to do this segment right here. Okay, so we need to do between 16 and 20. So between 16 seconds and 20 seconds. Our change in x would be, so at 20 seconds, the final position would be at -15 meters. And then minus, at 16 seconds, we were at 0 meters. So that would give you -15 minus 0, which gives you -15 meters. Now we need to go the next segment, which is between 20 seconds and 24 seconds. So my displacement, my change in position, okay, so at 24 seconds, we were at -6 meters, minus at 20 seconds, we were at -15 meters. So that means my delta x would be -6 plus 15, which would give you +9 meters. And that makes sense. Look, it went up, right? It went up because we went from -15 to -6. That the elevator had to go up. Okay. And then between 24 and 28, the displacement is going to be 0, right? Okay. So I'm going to add that one in just to show the mathematics behind it. So between 24 seconds and 28 seconds, our delta x would be, okay, so we ended up at 28 seconds, and that was at -6 meters minus, and at 24 seconds, we were at -6 meters. So that'd be -6 plus 6, or 0 meters. Okay, so all of that's going to help me get this distance traveled. Okay, so the distance traveled is all of these displacements added up, but without the signs, right? Okay, so starting between 8 and 16, we went -12, right? So that just means we went down 12 meters, but we traveled 12 meters. So we need to include 12 meters plus, and that was 8 to 16. Now we need to go 16 to 20, and that was -15. So we went down 15 more, but we really, what did we travel? We traveled 15 meters. So plus 15 meters. Okay, and then from 20 to 24, we went up 9 meters, but we also traveled 9 meters, so plus 9 meters. And then from 24 to 28, we went 0 meters, so plus 0 meters. We didn't change at all, okay? So adding these up, 12 and 15 makes 27, and 27 plus 9 makes 36. So this would be 36 meters. Okay? And that would be the distance traveled for this one. All right? And that's how you do these problems. Later on, we're going to be getting into position graphs and velocity graphs and also acceleration graphs. Okay? All right, guys, that's it. Hopefully this makes sense. If you have questions, feel free. If you do this before we get back on Zoom, just jump on Zoom and ask me questions, okay? Even in the middle of this, if you get stuck on something, ask questions, okay?